Here is my review or introduction, whichever for you, for trigonometry. Obviously, this can get really complicated when you take an actual trig class or something like in college. They can get pretty picky and do all kinds of things, but we're just going to cover the basics. And sine is one of our three basic functions, and these all involve right triangles. And sine is the ratio of the opposite side from the angle being discussed divided by the length of the hypotenuse. So I made a 30, 60, 90 right triangle. So that's the 90, and here's the 30, and this would be the 60. And if you're going to take the SATs, by the way, they think you know the ratio of a 30, 60, 90 triangle is 1 to 2 to square root of 3. And remember, the square root of 3 is like 1.4 something. Anyway, it's smaller than 2, and the hypotenuse of any right triangle has to be the longest, so that's the 2, because I have a temptation to make this the 2, but that's the 2. So the sine of any angle in a right triangle will be the ratio of the length of the opposite side over the length of the hypotenuse. And you can scale this up and down as big and small as you want, and the ratio will remain the same. So this always works for 30 degrees. It's always the same ratio. And in this one, the length would be 1 over 2. And so the sine of 30 degrees is 1/2. Now, since we know that these ratios have to remain the same, it means we could figure out something else. What if this was scaled up so that this side was 10? Then I could go and I could find the hypotenuse, couldn't I? Because the ratio needs to be 1/2. And some of you have already leaped to the conclusion that it must be 20, because this triangle must have been scaled up by a factor of 10 to 10 times the size if this is 10. And that would mean that this would be 20, right? That's true, but I'm going to do it the hard way, so to speak. Sine of 30 degrees equals 10 over hypotenuse. Now, the sine of 30, though, we said is a half, isn't it? This can be converted into 1/2. These are equal. So I can take any sine of 30 and shove in a half, and I'm not lying. That's mathematically true. So when I trade the sides here, and this one goes under, and the h comes over here because I need to solve for h, I get 10 over sine of 30 degrees. But sine of the 30 degrees is a half. And how many halves can you shove into 10? The answer is 20, which is what we said. So I could also solve for the opposite. Sine of 30 is a half. Notice I'm convert this to a half. And the ratio is opposite over hypotenuse. So y, I just called it y because it's up, so maybe it's y, is over 5. This over 5 will equal that. I know that's a half. So I pulled my 5 up over here. And now I have solved for y in a sense, and this is a half, and a half of 5 is 2.5. So what is y? It's 2.5. Cosine is the ratio of the adjacent side to the angle over hypotenuse. So you can scale this up and down as far as you want, but the ratio will be effectively square root of 3 over 2. So cosine of theta, in other words, the angle being discussed, and it's not the right angle. I should put it in the right angle, but you don't take sine or cosine or tangent of a right angle. You take those functions of a different angle in the triangle. Must be square root of 3 over 2. So I could solve for this because I know that, and I know that cosine of 30 degrees is 3 over 2. So how about we say cosine of 30 degrees then is equal to 5 adjacent over hypotenuse h. H is unknown. I need to pull this up here, and then the cosine of 30 goes down here, and I end up with this. But cosine of 30 degrees is square root of 3 over 2. Now, maybe you've heard me say stuff like the bottom of the bottom is the top of the top. And if you want to consider this as 5 over 1, then the 5 is the top of the top. There's make a fraction in the top of this big line. So I have 5 over 1 over square root of 3 over 2. The bottom of the bottom is the top of the top, which means I can grab this 2 and swing it up here and multiply by the 5, and that's legal. and I get 10 over square root of 3, and then you grab a calculator if you actually need a decimal, and I get this. I can also solve for the adjacent side, because cosine of 30 degrees must be x over 10. So I'm going to multiply this over here, because I can substitute the square root of 3 over 2 for this, multiply by 10, and you grab a calculator, you get that. Tangent is opposite over adjacent. So for 30 degrees, it'd be 1 over square root of 3. So if I needed to solve for adjacent, I would say, well, 1 over x is equal to tangent of 30, and tangent of 30 is 1 over square root of 3, right? So when I move this under here, I put the x over there, I get this, but this is so tangent 30 degrees moves under, but tangent of 30 degrees is 1 over square root of 3. And so the bottom of the bottom is the top of the top, so I get 1 times square root of 3 over 1. So I get square root of 3, and if you need a decimal, you grab a calculator and find out what it is. I can solve for the opposite side, because y over 5 must be equal to tangent of 30. I'm going to move the 5 up here. That solves for y. This is the same thing as that. And I get 5 over square root of 3, which I didn't write in there. And you probably need a decimal, so you grab a calculator and just find out what that is.